What do I want to do? I want to... You're looking at my screen, is that correct?
I am.
All right. Let me bring up my email and see what you said. Okay. First, the bottom one or the top one?
Let's start with the bottom one.
Looks like they're duplicates of one another.
They are. I didn't know what email to send them to, so I sent them to both.
Okay. David Cowan, 1949, gets to me the fastest.
I sent them to those as well.
Just for future reference, don't send it to the digital math tutor one. That has to be relayed to me. Okay. In other words,
I also sent them to that other email as well.
Yeah, no, that's fine. I'm glad you were very thorough there. But for future reference, the email that gets to me the quickest is davidcowan1949@gmail.
Okay.
Okay. Let me download these 3 files, and then I'll be able to open them up. We'll be in good shape here. Wow, this is such a funny looking screen. Can't believe it. It's so different. Guess it works though. Yeah. Okay. First file in there, second file over there, and third file. All right, let's open that first. The 71 is the start. 73 is the end.
Yes.
Okay. Open it with paint. Which will allow me to rotate it if I need to. Alright, so I need to rotate that 90 degrees left. Prove each of the figures is a parallelogram by the stated method. Okay, by definition, number 1. What's the definition of a parallelogram? See if you can figure it out and tell me what it is. Ben, are you there? Ben, did I lose you?
Hello?
I think I lost you for a moment.
Can you hear me?
I can hear you now, but I couldn't for about 15 seconds.
Okay, I heard what you said. Isn't a parallelogram, isn't it a four-sided figure with like opposite sides that are parallel?
And equal.
Like a equilateral? No, a quadrilateral.
It's a quadrilateral whose opposite sides are parallel and equal.
Okay.
Okay? So, I guess the question we need to figure out on number 1 is, are the opposite sides, actually if they're just parallel, if both opposite sides are parallel, it's a parallelogram. They will be equal by definition. So, what do we need to prove for number 1?
That the figures are parallel to the
Okay,
statement.
so what makes two things parallel? Two lines.
The two things that make it parallel, isn't it the distance and length?
No, slope.
Slope, yep, we have to use the
Slope is
slope.
what they teach you from the 8th grade on, and there's a reason for it. It's the most important concept in math all the way up through calculus. So whenever you're unsure, start with slope.
Okay.
Okay, what's the slope of the top line that goes through the y-axis?
The top line that goes to the y-axis, isn't it? The top line that goes to the y-axis, isn't it 2, 5?
Let's see, the rise over run. So the rise is going from 3 to 5, that's 2. The run is going from minus 3 to 2, that's 5. So 2 over 5 is correct. Is it positive or negative?
It is going to be positive.
Okay, what's the slope of the bottom, the opposite side?
The opposite side of the bottom, so the opposite side of the top one, it is negative 4, 0.
Rise over run. What's the rise?
The rise is, wouldn't it be 0?
You're going from minus 4 to minus 2.
Oh, yeah, okay.
So what's the rise?
Negative 2.
What's the run?
Isn't it 2 as well?
On the
No.
x-axis, what does it go from?
Oh, it goes from, are we looking at the bottom one?
The bottom line, opposite the very first line we started with. Think horizontally. In one case, when you think of rise, your eyes are going up and down.
Isn't it 8?
How far does it go from on the x-axis? From 1
8.
point? Does it? It goes from 0 to 5.
I don't.
Make sure you see why.
Okay, so 1, 2, 3, 4, 5. Okay.
Notice where that bottom left dot is. It's on the y-axis.
Yeah.
That means its x-coordinate is 0. Well,
okay.
What's the x-coordinate of the bottom right dot?
5.
Okay, the run is 5. Goes from 0 to 5. What's the rise? What's the bottom left dot?
The bottom left dot to 0, correct?
Now, make your eyes go vertically. If we're looking at rise, no, the bottom left dot is at minus 4.
Yeah, so we'll go...
From what? Minus 4 to what? Look vertically. Make your eyes go up and down, and now look at the lower right dot. What is it at?
The lower right dot is at negative 2.
Okay, so from negative 4 to negative 2, what is that?
2.
Okay, that's the rise. What was the run?
1, 2, 3, 5.
Okay, so 2/5. Is it positive or negative?
Negative.
No, look at the slope of that.
Wait, it's positive.
That's always the way to figure it out. Don't try to figure it out by the signs, because you can get confused very easily that way. Just make sure when you look at that line, you see a positive slope.
Okay.
Well, the top line was also 2/5, and it's also a positive slope. So what we've just proved is that the slope of the top line is the same as the slope of the bottom line.
Okay.
Now we have to do the same thing for the left and right lines. If they also have the same slope, then we have a parallelogram.
So the top right and the top left?
Yeah, let's start with Here, gee, I wonder, got drawing tools here. That would be fabulous if these work. Let me see if these work. Tell me the slope of that line. Hold on, maybe. Slope of that line right there. Rise over run.
So it goes over 3, up 3.
Make your eyes go vertical.
It goes up 3, over 3.
Hold on, just make sure you get the rise proper. You don't have the rise.
No, wow. It's
In
up,
other words, you're going
up
from
4.
this point here to this point, the rise in those 2 points.
Oh yeah, 1, 2,
Count it
set up 7.
Okay, what's the between
3.
left to right? Okay, over positive or negative?
Negative. No, positive.
Negative. Look at it. It's negative slope. Very important in geometry that you be able to distinguish between a positive and a negative slope. You can do it mathematically, but trust me, it's just easier if you know what a positive and negative slope look like.
Okay.
That's negative. If I put a ball right here, it's going downhill. Right?
Okay.
If I put a ball right there, it's going uphill. Sorry about my thing. But, so, over here, right, man, there's something wrong with my graphics tablet. I'm going to draw a bunch of slopes. You tell me if they're positive or negative. What's that? Put a
Isn't
ball
that
on top. If it goes uphill, it's positive. If it rolls
negative.
downhill,
Negative.
nope. It goes from
Negative.
lower left to upper right. Does it not?
So, yeah, but wouldn't it
That
roll?
makes it positive.
Okay, yeah. Okay.
Okay. This slope.
Negative.
Okay. What's this slope?
Negative.
Yeah, I meant to draw it horizontally. Perfectly horizontal line. What slope is that?
Positive.
No, it's 0. In other words, the rise is 0, regardless of what the run is. When you have 0 divided by another number, you get 0. So horizontal lines have a 0 slope. How about a vertical line? That's supposed to be vertical.
Would be a negative.
Undefined. The only line
undefined.
That's the only line that has an undefined slope is a perfectly vertical line.
Okay.
Okay. Okay, so let's go back to our number 1 problem. We're looking at the lower left line and the upper right line. What we're attempting to prove is that they have the same slope. If they have the same slope, then this is a parallelogram by definition. So we already figured out. Let me see if I can change the color here so that at least still coming out black. We figured out the slope on that line, right? It was -7/3.
Yeah.
So let's figure out the slope of the line that's opposite that. What's the rise?
So we're looking at the top left, right now.
Top right line.
Yeah.
Here, I'll put a check mark on it right there. What's the slope of that line?
So we're going from We're going to go from 1, 2, 3. We're going to go up 9.
Nope. I
Up.
tell you what, do it arithmetically. What's the difference between 5 and minus 2?
5, it's 3.
How many points is it on that y-axis to get from 5 to minus 2?
5, from positive 5 to minus 2.
Yeah, how far is that?
1, 2, 3, 4, 5, 6, 7, 8.
7.
How am I counting? 1, 2, 3.
There's 5 above the x-axis and there's 2 below. That's 7.
Okay.
What's the run? Goes from what to what?
Isn't it going from...
Make your eyes go horizontally now.
1.
Nope. What's the x-coordinate of the top point on that diagram?
7.
What's the x-coordinate? Your eyes are looking left to right, so you're on the x-axis. This point right here, what's the x-coordinate of it?
The x-coordinate is 2.
Okay. What's the x-coordinate of the bottom right point?
5.
Nope. Okay, yes. What's that difference? What's the run?
3.
Is it positive or negative?
Negative.
So we got minus 7/3 on that line, minus 7/3 on the line opposite it. Therefore, we have 2 lines that are parallel to their opposite sides. That fits the definition of a parallelogram.
Okay.
And that's all you need to prove it. You don't need distance. I was wrong when I said it turns out that those lines are the same length also. But that's not really the proof. The proof is all you have to do is prove it's a quadrilateral, 4-sided figure, and that the opposite sides are parallel to one another. Parallel is the same slope. All right. Let's see if I can figure out this program. I'll start by closing this out to get rid of all my ink. Wow. I am not impressed with their changes. Just a second. This might take me a little bit to figure out because I'm not used to what they're showing me here, and everything seems to be in slow motion besides. Well, how could they do this? How could they change this program to make it so much worse? Well, let's just continue with what you can see. Number 2. Sounds like you got the crud that everybody I know has. I've had the flu for a week.
I know. I don't feel good either. I missed school yesterday.
Oh, I just played bridge, and at least 75% of the bridge players were coughing, wheezing, sneezing. Unbelievable.
Yeah.
Not sure I've ever seen it this bad. But anyway, so hold on. Let me see if I can figure this out real quick. Over here and try that tool. It's not letting me click on it. Wow. Well, I think I can explain number 2 without writing. On number 2, we need to prove it's a parallelogram based on the opposite sides being congruent. What does that mean?
Like equal?
Yeah, equal measurement. In other words, another definition of a parallelogram is the opposite sides are equal.
Okay.
So how do we prove that those opposite sides are equal in distance?
We gotta find their measurements.
We need to use the distance formula.
Okay.
Number 2 is not about slope anymore. It's about distance. So we need to find the distance. See how far I can get. Need to
So
find
we'll
the
have to.
distance from there. Can you see that?
Yes.
Okay. What's the distance formula?
Like B equals x2 minus x1
Square root.
y2 minus 1. That's what I meant. D equals.
That make that your beginning thing. Why is it the square root? Because that's the hypotenuse of a triangle.
Okay.
See that triangle? Oh, God. Amazing how bad this is. See that little triangle I just drew?
Oh yeah.
Okay. What we're wanting to know is the hypotenuse of that triangle, right?
Yeah.
So the hypotenuse is, by definition, the square root of the sum of the square of the sum of the sides. So
Okay.
let me try and I know why right there. Can you read it?
Kinda, yeah.
Okay. So what hypotenuse is the sum of x squared plus y squared. See why?
Okay.
Based on the Pythagorean theorem. If you don't know the Pythagorean
Yeah.
theorem, memorize it, know it by heart. It's probably the most important theorem you're going to come across in geometry. It's how to
Okay.
right triangles. That's a right triangle. So the hypotenuse is, as you correctly stated, the square root of x sub 2 minus x sub 1 plus y sub 2 minus y sub 1. That x and y that I've drawn on the figure, that's x sub 2 minus x sub 1, is it not?
It is.
So what's x?
So X, we're looking at the bottom left, the mid left, correct?
Correct.
So X would be -5.
It's the difference. What's the distance of x? It's x sub 2 minus x sub 1. And guess what? The sign doesn't matter because you're going to square it anyway. So it doesn't matter if it's -2 or +2. Make your eyes go left to right. What's the difference between x sub 2 and x sub 1?
Gosh,
Where's x sub 1 at?
isn't X of 1, isn't it the left one on the left side?
Well, give me a number. Which number on the graph is it?
It's the isn't it -5, 1?
It's -5.
Yeah.
Forget the y for a moment. We're only concerned about the x. That's
Yeah.
what's confusing you, is you're trying to figure out both at once, and you don't know which way to make your eyes go. When we're talking about the x-coordinate difference, the only way we want to look is left to right.
Okay.
So the difference between point and point is what?
Isn't it?
How far is it?
Look.
-5
Isn't
to
it 3?
-3.
It's 2.
Okay, that's what x is 2. What's y?
Y is 1, isn't it?
What's the difference? Make your eyes go up and down.
Up and down. Okay.
What's the difference between this point and this point?
So it goes up 1, 2, 4.
Okay. So our distance is the square root of 2 squared plus 4 squared. What is that?
2 squared plus 4 squared. Squared plus 4 squared. I'm trying to think.
What's the difference?
2 squared plus hold
What's
on, let me
2
think.
squared?
2 squared. 2 squared. What does 2 squared equal?
What is it equal to?
I found this on the web.
Isn't it 1?
2
No,
times 2.
Yeah, it's 1.
2 squared means 2 times 2. 3 squared means 3 times 3. 4 squared means 4 times 4. What
4,
is
so it's
squared?
2.
What is 2 squared? 2 times 2.
Yeah, it's 4.
Okay. There's your 4 right there. Y was 4, right?
Yeah.
What's 4 squared?
16.
Okay. It's 4 plus 16.
20.
So it's square that distance. Oh man, this is so horrible. I really apologize for this. I'm not sure what I'm going to be able to do to solve this, but I'll get it solved. So square root of 20 is the distance of that top left line. You know, square root of 20. Oh man. So what we have to do is to prove its opposite side has the same distance.
Okay.
Same distance formula. It's the square root of the difference in the x-coordinates squared plus the difference in the y-coordinates squared. And that's really the best way to look at it. In other words, you can memorize it as the square root of x sub 2 minus x sub 1 plus y sub 2 minus y sub 1 all squared. But that's not the way to do it. The way to think about it is that we're always calculating the hypotenuse of a right triangle. So, on the opposite side, what is the difference in the x-coordinates?
So the difference between the x coordinates, so I'd go over.
We both sound like we need to be in a hospital.
I know, I don't feel good either. Ow. So I'm looking from I gotta go up and down.
No, x is left
right,
and right.
left and right. So if I'm looking at the other side, I'm going from left to right. So the difference is 1, 2, 3, 4.
Nope.
What?
You're looking up and down. We're going left to right. What's the x-coordinate on the bottom point you see on that drawing?
The bottom coordinate, it's 2. It's
No,
negative
it
2.
isn't. That's the y-coordinate. The x-coordinate is minus 1.
Oh, okay.
What's the x-coordinate of the far right point?
The far right, 1.
Okay, what's the difference between those two?
1, isn't it? So it goes from...
Count them. Go from minus 1 to 1. How much do you have to count?
1, 2.
Okay, it's 2. So the difference in the x-coordinates is 2. What's the difference in the y-coordinates?
Gosh dang it.
Y
The y
coordinates is you're going up and down. That's the only thing you care about. What's the difference between the y coordinate of the bottom point and the y coordinate of the far right point?
So it'd go up, so it'd be 8.
You're going from -2 to 2.
Oh, minus, where the 2? Oh, I see, yeah. 1, 2, 3, 4.
Okay. So now, again, we have the square root of 2 squared plus 4 squared. Again, that's the square root of 20.
Okay.
So those two sides have the same measurement.
Correct.
Now, let's look at that line. If we can prove that those two have the same distance, then this is a parallelogram. So, I want to keep on this because you need work on this. The bottom left line, what's the x coordinate?
Bottom left line. It's not the complete bottom with the bottom left. The x coordinate is -5, correct?
What's the difference in the x coordinates?
From the bottom left to the right one?
Okay, let me put another check mark on this line. See that check mark?
No.
You don't see that check mark. Can you minimize your GoToMeeting screen? There's 2 arrows that point towards one another.
Let's see.
If you're able to minimize it, then you'll see more of my screen. It doesn't look like you're seeing my full screen.
Okay. Wait, make one more check mark. Let's see.
That line right there.
Oh, yeah, okay.
3 check marks through it.
Yep.
Okay. We need to figure out the distance of that line.
Okay.
So know the distance. Here's a good way to memorize distance. Distance equals the square root of delta x squared. Delta x means x sub 2 minus x sub 1 plus delta y squared. So what is delta x?
Delta x, so that's the x coordinate.
And again, it doesn't matter whether it's positive or negative. We're going to square it.
5.
Nope. Where's it going from?
It's going from top to, what the heck?
Just make your eyes go left to right and look at only the x coordinate.
It's going to 1, isn't it?
It's going from -5 to -1. Is it not?
Yeah, it is.
How far?
But how do you do -1 when it looks like it? What? Okay. Okay.
So what's that distance?
So from -5 to -1 is 4.
Okay. So that's delta x is 4. So that's going to be 4 squared. Right. What's delta y?
Delta y, you're going from 5.
Nope. There's no 5 in the delta y. You're looking at the x coordinate again. Got to make your eyes go up and down only.
So 3?
Yes. So it's 4 squared plus 3 squared. What is that?
Let me think. What's 4 squared plus 3 squared?
Well, doing one at a time. What's 4 squared?
Isn't it 25?
Okay, what's square root of 25?
5.
That's
square root of 5.
That's the distance of that line is 5.
The square root.
Now we have to see what the distance of the side opposite that side is.
Okay, so the square root of 25 is 5.
Right. So we know it's 5. If we can prove its opposite side is also 5, then it's a parallelogram. So what's the distance of the opposite side when it only has one check mark through it?
The one that only has one check mark through.
Well, the opposite side of the line we just worked with.
Oh, yeah. So
What's the delta x?
delta x, isn't it 3 as well?
Count.
No, it's -1.
There's no -1. It goes from -3 to +1.
-3 to +1, correct. So then I'm going over 4.
Okay. What's the difference in the y-coordinates?
The y-coordinates is, the difference is I'm going from, aren't I going from 5 to -2?
You're going from 5 to +2. We're talking to this point always. You're only talking about the two endpoints. Forget that point way down at -2. We're not on that line anymore. So what's the difference in the y-coordinates?
Isn't it 3? No, it's 2. Yeah, no, 3.
5 minus 2 is 3.
It's 3, yeah.
So again, it's 4 squared plus 3 squared. That's 25. Square root of 25 is 5.
So it's the same.
It's the same, and we've just proved that it's a parallelogram.
Okay.
Okay?
Now, the one thing about this is, I understand it somewhat, but there's only one on like the test, so that's not too bad.
Well, no, not really, Ben. This is hugely important. And you need practice at these. More practice. Question is, can I figure out how to look at the rest of this page?
No, that's the only problems on that page.
Oh, these two problems are the only problems?
Yep.
So all I got to do is figure out how to get out of this. Well, let me start by changing the drawing tools. Let's see if that does anything. Wow. Seem to be hung. Not registering any keystroke that I hit. There for a minute. I can't even scroll up and down on this thing. Well, let me try a Control-Alt-Delete. Task Manager. See if I can close it out under Task Manager. Ha! There's no running app. Oh, there is. Paint. That's what I want to try to close out. Can you see all this stuff coming up on my screen?
Yeah.
Yeah, unfortunately, it's not letting me type or indicate, but I want to close out Paint. What else can I do here? Wow. Hi. I'm not quite sure what to do other than to reboot my computer, and that'll take like 10 minutes, and we only have 12 minutes. So, what else can I do here? Do you have to leave exactly at 5?
I do. I have practice right after.
Okay. normal drawing. No arrow. Let's see what happens when I put arrow in there. Didn't help. But at least I got it to register. Remember what I did? Get it register. Wow. This might be the worst change I've ever seen in a program. I wonder if this has anything to do with all the problems I'm having as their new program. It's basically not letting me access anything. Hold on, let's see. Okay, hold on. I think I can probably erase things. Okay, well, I made progress. Now let's see if I can close it out. No. Try this. Erase, arrow, normal drawing mode. Let's try that. Okay, good. I think I'm getting it figured out. Yeah, okay. Let's try opening up the second page. Okay, we went 1, 2, 6. Is that correct?
Correct.
All right. So how are we going to figure out the measurement of each side?
So it might be as simple as it sounds, but don't I just set them equal to each other?
Yep. So give me some equations.
So when I do 3x minus 5 equals x plus 4.
Okay, let me start writing. Hold on. So I got 3x minus 5 equals what? It's right off my screen.
3x minus 5 equals x plus 4.
Can you solve that for x?
Yeah, so 3x minus 5 equals x plus 4. You're going to add the 5
Okay.
to the 4. You're going to get 9.
Nope. Got to add 5 to 4.
Oh, yeah, add 5 to 4.
Oh, I'm sorry. It is 9.
Yeah, okay, so it's 3.
Now you got to move the x's all onto the other side.
Yep, so you add the 5, you get the 9, then you subtract the x, subtract an x, then you get 2x equals 9. Divide that 5.
Okay, that solves for x. Now, solve for y.
Then you get 21 minus 3y equals 18 minus 2y.
Where are you getting 18 from?
The
21
bottom.
minus 3y equals x plus 4, right?
Oh, yeah.
What's x?
X is 4.5.
Okay, so 21 minus 3y equals what?
21 minus 3y is 18.
What's 4.5 plus 4?
8.5.
Okay, there's our equation. Solve that for y.
So then you'll do.
I would write it back here like I'm harming you rather than helping you if I try to write something here.
So you're all good. And then subtract 21, and you'll get minus 8.5. You'll get negative 12.5.
Positive 12.5?
Oh, yeah. Oh, yeah. My bad. Then you will have, it'll equal 3y.
Okay.
Divide 3y. So then you'll get 12.5 divided by 3. You'll get 4.16, which will turn into 4.2.
And that's y.
Y equals 4.2.
And so you've solved for x and y.
Yep.
Okay. Let's see how much I've learned here. That's not helping. Well, I guess I can just, hold on. I don't want to do that. What do I want to do here? Okay, second one. What do you know about the angles when there is a diagonal going through the parallelogram? Number 7.
I forget the word for it, but aren't they like equal? So like
that line, that diagonal bisects those angles.
Yeah. So like 13's equal to x plus 2y.
No. Well, that also is true, but that's the hard way to do it. About 13 equals, if you said the line bisects those angles, what does that mean? It means 13 equals 3y plus 26.
Yeah, so 13.
Solve that for y.
13 plus 3y equals 26.
No. 13 equals 3y.
Oh, why is it 13 equals 3y plus 26? You will subtract the 26. That will give you negative 13.
Okay. That's y
equals y. Divide by that, you will get 13. 13 divided by 3.
Negative.
Yeah, 13.
Y equals negative.
Divided by 3 is negative 4.3.
Yeah, I'm not real fond of converting these to decimals. You're better off if you leave them as a ratio. The ratio is always exact. When you convert it to a decimal, you're rounding it off.
Okay.
So what y is really equal to is minus 13 thirds.
Minus 13 thirds.
You see how you get that?
Yeah.
Okay, now let's do the same thing with x.
So then 7x plus 3
equals
x plus 2y.
And what is y?
Y is negative 13 thirds.
Okay, now solve that equation for x.
5. So you will, okay, hold up. So that's plus, that's an x. So then you're going to subtract 3x, 3x. So you're going to get 5.
Remember y is minus 13 thirds.
Okay, so it'll be.
I'm going to attempt to write here. See how successful. Not very. Wow. Try this one different method here. Oh man. Hold on, I might be getting somewhere here. Let's just try this for a second. Maybe my writing tool will work a little bit better. Okay, so our equation is 7x plus 3 equals what?
7x plus 3 equals x plus 2, and then in parentheses you will have 13 thirds.
Minus 13 thirds. You cannot drop negative signs. If you drop negative signs, you're always getting the wrong answer. Okay?
Correct. Yeah.
Okay. Now, gather all your x's on one side, all your numbers on another. How many x's do we have on the left?
I solved it, so wouldn't x equal, if I did this right, x equals negative 8 over 3? Because then you'll move it over, so then you will have
3. Ooh, this
negative 6x.
This does solve my drawing problems. Amazing. Right?
Minus 2, yep.
Okay. Now, let's, doesn't totally solve it, but. So, minus 3 is how many thirds? It's minus 9 thirds, right?
Yep, so
6 thirds. So 6x equals minus 35 thirds. Now what?
So then you'll divide
By
6.
Okay, so x is going to equal minus 35 divided by 6 times 3, 18. And it's
18,
negative.
correct.
And it's negative.
Yep.
Negative 35/18 is x.
Okay.
Okay? So, we actually covered quite a bit today.
Yeah,
the most important two things we learned today is how you figure out the slope of a line and how you figure out the measurement of a line, that is the diagonal. In other words, it's not a horizontal line or a vertical line. Those are easy to figure out the measurements of. The hard ones are the ones that have a diagonal aspect to them.
Correct.
And just always remember that that diagonal is the hypotenuse of a right triangle.
Yes.
So it's always the Pythagorean theorem. It's the square root of the delta x squared plus the delta y squared. Those are the two most important things you learn. What we covered on the second page is just algebra. It's not geometry anymore. It's algebra.
Okay.
Okay? But the first page was all geometry. You need algebra also, but it was more geometry than this page is.
Perfect. Okay.
Okay?
Sounds good. Thank you.
All right, Ben. Sorry for all the difficulties on my end.
It's all good.
You're my first session with this new software they sent me.
It's crazy. Weird, yeah.
It's horrible. I can't believe what they did. What a change. At least they should have warned me.
Yeah.
So, anyway, enjoy the rest of your day, and I'll talk to you next time.
You too. Sounds good. Okay. Bye.